Okay, so I'm pretty sure you had a good break. Alright, now we're gonna move on to least common multiple. So you have some understanding about greatest common factor, right? Now let's think about least common multiple. Similar to greatest common factor, we need to think about the definition, the meaning of least common multiple. So we need to find the multiples of the given numbers. Then you're gonna find what are the common multiples then between those two numbers. Then among the list of common multiples, what is the least, the smallest common multiple? So that's the basic notion, the definition about the least common multiple, right? So the least common multiple of two non-zero whole numbers, a and b, is the least non-zero whole number that is simultaneously, which means common, a multiple of a and multiple of b. So there are several ways to represent that situation to find the greatest common least common multiple. For example, to find the least common multiple of 3 and 4, you can see the multiples of 3 and multiples of 4. If you use the number line like this example, you can do multiples of 3 first. Multiples of 3s are to keep adding 3, and where do you land? Those numbers are multiples of 3. So 3, 6, 9, 12, 15, 18, and so on. They are the multiples of 3. And there are infinitely many multiples, right? Unlike the factors or divisor that are limited number. So we are finding among the limited number, you can find the greatest common factor. But for the multiples, it goes on and on and on. There are infinitely many multiples. So you cannot find the greatest common multiple. It's not possible. That's why we are finding the least common multiple between two numbers, okay? So we found the multiples of 3, and let's do the same thing for multiples of 4. We can keep adding 4 to find the multiples of 4, which is 4, 8, 12, 16, 20, etc., etc. So we see what's the least common multiple. So what is the common multiple? Well, these two are not common, not common, not common. But we see that these numbers here, both red arrow and green arrows, both fall on 12. So 12 is the one of the common multiples, right? Of course, there are more on 24 and 36. They are all common multiples. But the least common multiple out of that list is, of course, 12. So you can find the least common multiple using the number line like that. If we use a Cuisenaire rod, just like the common divisor, common factors, you can do that too. So you keep adding this green rod, right, to show the multiples of 3. So this is 3 times 1, 3 times 2, 3 times 3, 3 times 4, etc., etc. 4 rods. You continue adding until you can find the common ends, so you can have exactly same number there, right? So between purple and green, if you have 3 purple and 4 greens, you have exactly same length there. That is the least, the smallest stick that you can use, smallest rod you can use, and apparently that is 12, right? So that's how you can find the least common multiple. But it doesn't work. I mean, you can still do that, but it takes so much time for bigger numbers, right? Another way is, this is commonly used too, just list all the multiples for 8 and list all the multiples of 12. And then you find the common multiples, so like 24, 48, 72, etc., etc. And then you figure out, oh, among those multiples, I see 24 is the least common multiple. Okay, so you can do that. But for bigger number, it's still tedious. So we are going to use our favorite model prime factorization method. This is for upper elementary level, right? So you can extend this to your algebra in middle school and high school too. It's very, very useful, prime factorization method. It's very similar to greatest common factor, to find the greatest common factor, we use a prime factorization method too, right? So it's very similar, but there is difference, of course, too. So how do we use prime factorization to find the LCM? If you have two non-zero whole numbers, we first find the prime factorization, right? Then we take each of the primes that are factors of either of the given numbers, because we need to find the common, right? The LCM is the product of these primes, each raised to the greatest power of the prime that occurs in either of the prime factorization. That is the difference between finding LCM and GCD. In finding GCD, we saw the lowest power of the prime between those two, okay? But for our LCM, even if it's the least common multiple, because it's multiple, we are looking at the greatest power. Okay, so I'm gonna start with this example. Okay, we need to find the least common multiple of 2,520 and 10,530. So let me use this Jamboard. Okay, so it says find LCM, least common multiple of 2,520 and 10,530. If you are trying to find the list of multiples, like multiples of 2,520 and multiples of 10,530, it takes so much time, right? So 2,520, 2,500, I cannot even say that. 2,520 times 2, what is it? 5,040, and so on and so on. It's already hard, so I'm not gonna do this and find the common multiples, okay? So instead of doing that, we want to use prime factorization. So let's do prime factorization of both numbers. So 2,520, I see that it ends with 0, which means it's multiple of 10. So we know that 2,520 has factors of 250 and 10. Of course, both of them are not prime number yet. And I see that ends with a 2, so it's divisible by 2 because it's even number. And 252 divided by 2 is 126. And continue. And also, again, it's divisible by 2 and 2, 6, 2, 3. Okay, 63. It's divisible by 3, so 32, 31. Still 3 times 7. All of them are prime numbers, but we still have 10 and we are not done. So now we are done. Now we have 2,520 with all the factors. Let's reorganize that in a nice way from the smallest factor, which is 2. 2 to the what power? We have 1, 2, 3, 2. So 2 to the cube. And we have 3 as factors, and I have 2 of them. So 3 squared, 3 times 3. And then I have 5 times 7. So that's 5 times 7. Right? So 2,520 is 2 cubed times 3 squared times 5, 7. So let me rewrite that. 2,520 equals 2 cubed times 3 squared times 5 times 7. I'm just rewriting this because I want to compare the prime factorization of that with the prime factorization of 10,530. So let's look at 10,530. Do the prime factorization again. I know this is divisible by 10. Yeah, because it ends with a 0, and 10 times 1,053, right? And is this divisible by 3? Yes. So divide that by 3. And let me just do with my calculator. and divided 3 is 351. So we have the factor is 351 divided by another 3. Yeah, because 3 plus 5 plus 1 is 9. So divided by 3 again, and I get 117 and 3. And let's add them together. It's 9. So yeah, that means it's divisible by 3. So divided by 3 again, and I get 39. And 39 is of course divisible by 3 with 13. And 13 is another prime. So we are done with this part, but we still have 10. So 2 and 5. Now we have all the prime numbers here. And let's just write it here. We have 2 as a factor, but that's the only 2. So that's 2 times. How about 3? We have 1, 2, 3, 4. 3 to the 4th. And we have 5 times 5. And we don't have 7, so I'm gonna just have some space there, but still multiply that by the last number, 13. So we see what is in common. We see 2 is common, whatever that raised, and 3 to the something, and 5, right? And these 2 you don't even have to think about that as a common, but you need to remember this is a common multiple. Not only common, but you need to consider that multiple that comes before common. Okay, so when you are doing that, the least common multiple, you need to look at the raised higher exponent between those two if it is a common. Okay, so you have a common factor of 2, then go with higher exponent, 2 cubed, because it's multiple. Okay, in between 3, instead of squared, 3 to the 4th, take that. Between 5, oh, just 5 because it's same. How about what are we gonna do with the 7 and 13? They are not common, but it's a multiple. To get the multiple of that number without multiplying that by these by 7, you cannot get this number. So you have to multiply whatever is left over. So write all the common things with higher exponent, and then multiply the rest of it. Okay, so all of them together, then your answer for this least common multiple will be really big number, right? Which is 249,840. That's how you use prime factorization to find the least common multiple. Okay, so that shows there. Okay, so here is another theorem. For any two non-zero whole numbers a and b, if you are given two numbers and you found greatest common divisor of these two numbers and you found least common multiple of those two numbers, then the relationship here is the product of those two numbers is the same as greatest common divisor times least common multiple. Okay? Before I give you the example 16, I'm gonna use one of the examples that we did here. This is a really big number, so let's go with a smaller number, like this one. I think this is good. Okay, so we found the GCD as 36 here. Let me actually erase this one, okay, because we have done that before. Let me just erase it because I'm going to just use the GCD of it. Oh, sorry. How about I will just rewrite that. Okay, let me copy that down. So I have GCD of 108 and 72 as 36, right? Okay. Let me just clean that. And let's solve this kind of problem. Okay, GCD of 108 and 72, we already found that in the last video, which is 36. Now, can we find the least common multiple of 108 and 72 as well? Let's use a prime factorization. So 108, we can do the prime factorization, and 72, we can still do that. So it is divisible by what? 2? 2 times 5, 2 times 4. 54 is also divisible by 54, and we have 28. No, it's not. 27, right? 2, 2, 40, and 17, I mean 14, so yeah. Okay, so 27 is 3 times 9, and 9 is 3 times 3. So 108 can be written as 2 squared times 3 cubed. How about 72? It's 8 times 9, so we have 2 cubed, right? 2 times 2, because it's 4. So 2, 2, 2, and 9 is 3 times 3. So 2 cubed and 3 squared is 72. 2 cubed times 3 squared. Okay, that's how we found 36 as 2 squared times 3 squared, right? So GCD was 2 squared times 3 squared. Quick review. Okay, and LCM can be written as what? 2 cubed. We're gonna look at what is the larger exponent. What is the larger exponent? 3 cubed, right? That is your LCM. So if we calculate that, this is what? 8 times 27. 27 is equal to 216. So we found the GCD of these two numbers is 36. The LCM is 216. Then let me show you some fun things here. So if you multiply GCD and LCM of 108 and 72, we can multiply 36 times 216, right? So times, I get 7,776 for that. And I'm gonna ask you to multiply 108 times 72. What is 108 times 72? If you do that using calculator, oh, I still get 7,776. So that's the theorem that we just found, okay? So here is an important theorem. GCD of two numbers times LCM of those two numbers is the same as just product of those two numbers, okay? That's the theorem that we just talked about, okay? All right. Well, we can prove it too, but we will skip that for now. But we're gonna do some other questions. Okay, some other question, like this one. You wanna find the LCM. Well, of course, you can use the prime factorization. But let's do something else, okay? Using this theorem, we can still find the LCM because we know how to find GCD easily. Okay, so you're gonna find LCM of 731 and 952. So there are a lot of different ways. You can use a prime factorization to find it, or you can use list of them and find the common multiples, but it takes time. But there's another way that you can do it by finding GCD of 731 and 952 first. So I'm going to show you how to do that. Okay, so in order to find GCD of 731 and 952, we can also do prime factorization of both, right? So both are divisible by 17. So if you do 731 divided by 17, it's 43. And of course, 17 and 43 are both prime numbers. How about 952? 952. Let's see if it's divisible by 17 too. 952 divided by 17. Oh yeah, it is. 17 times 56. So 17 is prime, 56 is not. But that's 7 times 8, and we know 8 is 2 cubed, right? So now we have only the prime numbers. Okay, so 731 is 17 times 43, and 952 is 2 cubed times 7 times 17. Compare those two to find the GCD. What is in common? Only 17 is in common. So that is the greatest common divisor, greatest common factor. Okay? Once we found the greatest common factor, you can also think about product of 731 and 952 is equal to GCD times LCM of 731 and 952. But GCD, we already found that is 17. But we are looking for what LCM of these two numbers are, right? Okay, but we know how we can find the product easily. 731 times 952 is equal to 695912. You barely make mistake on doing this, right? Because you can just punch the calculator. So 695912, 695,912. Well, to find the LCM, since it's multiplied by 17, we can divide both sides of the equation by 17. This is same as you are multiplying both sides by 1/17. So the property name for this one is, yes, multiplication property of equality. The equality doesn't change when you multiply same number on both sides of equation. Okay, so LCM is equal to LCM of 731 and 952 is equal to whatever the quotient is. So divide this number by 17 and I get 40,936. So without doing all of that again, you can just do LCM in this way. Can we check that using the prime factorization? Of course we can, right? So compare those. 17, yes, that's common. So using the prime factorization to find the LCM of those two numbers is starting from 17. Because it's common, you write that only once. And the rest of it, because it's multiple, you need to multiply all that. 2 cubed, 7, and 43. All of them. You need to multiply all those three numbers. Then use the calculator to check. You still get 40,936. So you can check either way. Okay? Alright. So we can use this theorem to find the LCM. Alright. And these two questions are from your homework example. And these are kind of hard problems. So I want you to think about how to solve this one and actually jump into the problems and solve the problems. Okay? Pause the video, solve them, and then come back. Alright, so we have these two questions and let me solve them here. Alright, so the first question is asking to find produce the least positive number that is divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So a certain number is divisible by any of these numbers. What do we say? That has to be multiple of 2, multiple of 3, multiple of 4, multiple of 5, multiple of 6, multiple of 11. That number has to be, right? So we are looking for the least common multiple of all of these numbers. That's what we are looking for, right? So once you understood the question, now what can we do? We just find the least common multiple of these numbers, right? So 2, let's use the prime factorization. 2 is 2. 3 is also prime, so 3 is 3. How about 4? 2 squared is 4. 5. 5 is 5. It's already prime. 6. 2 times 3. 7. Oh, let me rewrite 3 because I want to line up with the same factor. So I'm going to write 3 here. Okay, by just lining that up. 7. I'm going to put 5 too. Let's move 5 to 3. How about 5 here? 5 is 5. And 7 is 7. So I'm going to just write 7. 7 equals 7. And 8. 8 is 2 cubed. So under 2 lines, columns. 9. 3 squared. So under 3 columns, you can put 3 squared. And then 10. 10 is 2 times 5. So under 5 columns. Mine is not really straight, but sorry. We know what that means. So 11 is just 11. So we see every factors here in prime factorization. To find least common multiple, you need to find what is in common first, right? So I see 2's here. Among that, what do we take? The biggest exponent, which is third, right? And we have 3's here. What's the greatest factor? Greatest exponent? 3 squared. Next one is just 5. So take either one. Take either one. And then we have 7. Take either one. And we have 11. So you just multiply all of these numbers together. So least common multiple of that, all of these is equal to 2 cubed times 3 squared times 5 times 7 times 11. If you punch your calculator, you will have this number, 27,720. That is the least number that is divisible by all of these numbers. Okay, because it's the least common multiple. If if you cannot understand this question, please go back to the problem here. Okay, and understand the question. Once you find that out, I have to find the least common multiple. Think about how to find it, and we watch this part. Okay, and the second question is asking you to find all possible values of a and b when greatest common divisor of those two numbers is 18 and least common multiple is 720. So we just learned the theorem, right? So we are given let me use black for the question. Okay, so GCD of A, B, this is given, is 18, and LCM of AB is also given as 720. When you are given these two, what else do we know? We also know A times B is equal to product of GCD and LCM. So 18 times 720, right? So if we do 18 times 720, we can find whatever that is. But that's not what our question is asking us to do. It's asking find all possible values of A and B. So you need to think about what could be A and what could be B, right? That's the question. So again, pause the video and I want you to really think really hard about this because it's not an easy problem. Okay, so you are back. Maybe some of you already have found the answer, some of you are still struggling. Please listen carefully, okay? Okay, now we know A times B is this, but what we need to know is greatest common factor of two numbers is 18. Greatest common factor is 18. So we know that A can be written as 18 times something, and B can be also written as 18 times something, because that's the greatest common factor, right? If we use some other numbers, you have a problem there, right? So if I just, well, we can always switch these to around 2. So I will just have, just fixing one number just different from the other. Okay, so if I take A as 18, then rest of the number 720 have to go to the other side, right? So that could be one combination. One number is 18, the other number is 18 times 720, or vice versa. Okay, that could be one. Or I can think about the prime factorization of 720, because that's the LCM. And if I do that, I know 70 times 10 is 720, and 72 is 8 times 9. 8 is 2 cubed. 9 is 3 squared. 10 is 2, 5. We are done with prime factorization, and we have 2 to the 3 and 4, fourth power, times 3 squared times 5, right? That's LCM. So you can just, separate this and multiply that by, either number. So I know A and B both has to be 18 times something, but differently, because there's no other common factor than 18. So if you distribute, if you give 2 to the 4th power to one number, the rest of them can go to the other one. If you give 2 squared here and 2 squared there, by breaking 2 to the 4th, for example, then what happens? 18 is not greatest common factor anymore. This becomes the greatest common factor, right? That's why we have to separate, the whole chunk of same base of the factors. Okay, so if you give 2 to the 4th here, the rest goes to the other, or vice versa, always. So if we keep doing that, we know that A and B is 18 times 18 times differently. If I give 3 squared to one number, the other 2 to the 4th and 5 goes to the other. These are all different combination, right? And if we continue doing that, I can also have A equals 18 times 5, and B can be 18 times the other 2 combination, 2 to the 4th and 3 squared. Is there anything else? Well, 1 times the whole thing, we already did that, 1 times the whole thing, right? So we did 2 to the 4th, 3 to the square, 5. Yeah, that's it. That's the only combination, the possible A's and B's. So one number can be 18. Let me use different color. For the answer, A can be 18. Then the other number is 18 times 720. What's that? 18 times 720. Oh, sorry. 18 times 720 is 12,960. So these are the two number combination, or 18 times 2 to the 4th, and you get 288, and 18 times 3 squared times 5, 810. That's another combination. Okay, two different numbers. Or 18 times 3 squared, 162, and that is 1440. That's another combination for two numbers. And 18 times 5 is 90, and this is 2592. So these are the possible numbers for A and B. Okay, so these are the pairs. All right, so there are a lot of hard stuff there. Okay, and I strongly encourage you to rewatch the video and solve the problems without my explanation. Okay, and if you have any question, please contact me. All right, that's it for today. please practice a lot of problems for greatest common factor and this common multiple. Okay, because it's not an easy concept. All right, great job, and I will see you next time. Bye.